This video illustrates how thin section porosity can be measured using image analysis. The method can only be applied when the porosity has been stained. There may be several different softwares around that can do this, but I am using a free software called ImageJ. ImageJ has a lot of available functions, but I will just demonstrate how thin section porosity can be measured. The program opens up showing a small window with a menu, as we see here in the upper left corner of the screen. The first thing we need to do is to drag a thin section image into the window. We'll use this file here. The thin section image opens up in a new window. We then select Analyze and Measure. A new window opens which shows the total number of pixels in the image. That's this number here. We then select from the menu Image, Adjust and Color Threshold. A new window opens showing the threshold colors. As default, the color space is set to HSB. That's here. I often find it easier to use RGB, so I will switch to this. The minimum and maximum numbers of red, green and blue should be set to values that replicate the porosity color. In my samples, as a starting point, I set the range for red to 0 to 100, For green, I set it to 0 to 255 as a starting point. And as a starting point for blue, I set it to 140 to 255. Using the original and filtered buttons down here to the left, we can switch between the original and filtered images to optimize the color ranges in such a way that the porosity is correctly captured. If I click the original, we see the original image with blue as the porosity, and clicking the filtered button, we see the filtered image with red as the porosity. If the red and the blue do not replicate each other, we should fine-tune the color values up here. When the filtered image looks fine, we click the Select button, and all pore boundaries will be marked by yellow lines. We then once again select from the menu Analyze and Measure, and the number of porosity pixels is displayed as a second row in the results window. That's this number here, 75,709. The fractional porosity is simply the porosity pixels divided by the total pixels, or row 2 divided by row 1. In this case, the fractional porosity is 0.096 or 9.6%.